Hello everyone, my name is Gaurav Shah. I currently serve as an assistant professor in the Department of Civil Engineering, NIT Rourkela. I used to teach this subject engineering mechanics earlier. In fact, last year also, last academic year also, I taught this subject. This semester, I thought that I will offer this as an online course where you can attend and learn about this course from online as well. Before I start, this is going to be an introductory class where I'm going to explain, who all can attend this course, what are your expectation, why you should watch this video. Let me give you a very basic idea here. When am I recording this course? I'm not teaching as a professor. Rather, I would say that 2007 when I attended my engineering mechanics course in the first year. uh, I started with this with a lot of hesitation. Hesitation means, engineering mechanics appear to be very difficult for me. Probably I have not paid attention, or probably the course instructor who are there probably has not given has not taught the way I wanted, right? So every student has their own way of learning things, right? Now, probably my frequency didn't sync with the professor or the lecturers. So somehow it became very difficult for me. Later on, I had to struggle because I studied in civil engineering. It becomes very difficult to go ahead in civil engineering without learning engineering mechanics, right? So I had to struggle a little bit to go ahead this course. And just not me, I have seen that along with me, a lot of my batchmates also has struggled with this subject. Uh, Later on, a different semester, what we used to do it as a group. Many times, let's say I used to understand a few subject better than others, and then all the batchmates used to come to me, and I used to help them understand and help them explain things in such a way that they can understand. I mean, in fact, they also used to do the same thing. When we used to reach out to them, they could also help me to understand the subject the way I actually can understand in a better way, right? So, I am going to teach in this subject not as a professor, rather, I will try to teach this subject the way I used to teach this, or help my friends to understand at the last moment when, like, you have just only 1 month, you're away from the semester. So, this is not going to be a completely, professional type of course. I will jumble things here and there, and then I will probably try to make things in a non-linear way, which makes sense for you to understand different concept rather than touching on different syllabus. But overall, if you follow the lecture series, I think you will be able to understand the core concept, and then using that, I think in the exam also you should be able to get a decent marks, I believe. Because here we are not going to go very deep into the subject. We are going to be probably, like, base. After that, little bit above the base, we are going to build not a very advanced course. In fact, in NPTEL you will find the engineering mechanics course which goes in a very deep concept of that. So we are not going to go that deep. We are going to go more like, base plus a little bit higher level. But this should be quite good enough for you to take this course forward and at least get a good decent marks. So that is number one. Number two is, who can attend this course? See, engineering mechanics is a course for all the BTech and BTech's, courses, right? For example, like, be it your computer science or mining or ceramic engineering, food engineering, civil engineering, from every specialization, engineering mechanics is a common thing, right? So I expect all of you, those who have just enrolled into the first year and then trying to learn this subject, and somehow you are not getting the flow along with the classes that you are attending. So probably this will help you to build your base and give you some level of supplementary resources to pick up where your professor or your lecturers are right now going on. So basically, all the first year students, those who are starting, can start this course. Now, today, let me go to the slide. So before I go to the go to the engineering mechanics core curriculum, now here I would like to take a pause, and I would like to ask you this, like, probably you have taken different types of specialization. What do you think? Why we are offering engineering mechanics as a part of, like, your engineering curriculum? Because it may not be that way, that it is anyway connected to your subject or anyway connected to your specialization that you are learning, right? This can happen, right? So for this matter, I am going to give you some basis, like, why do I think that this is very important. uh, this is what I think, but that may not be the case. This is how I try to rationalize why this subject being given to you. I mean, you can pause the video here and you can just give your thought, like, okay, why did the people introduce this course to you? I think, engineering mechanics, it gives you a framework to think. Let me explain that. Remember when last time, not last time, remember when first time you started training your brain systematically? I think the first time that you started thinking very rationally is when you have done the simplification math, where plus, minus, multiplication, division within brackets, all those calculation that you have done. Simplification had a formula, right? Okay, you go for division, you go for multiplication, you follow this order, that order. You followed a particular order. Now you see there is no use of simplification right now because you have calculator, you have computer. There is no need for you to actually do the math, right? Especially in a very complex scenario where plus, minus, division, brackets, all those things are there. We do not do that in real life, right? So if we do not do in the real life, so then I mean, you may ask, like, so what is the use? Well, I think that it's the very first time you started thinking very systematic rule based order. That means, okay, okay, out of all the sign, look for this sign. If this sign is there, you solve this problem first and then you move to the next one. In a very early age, when you were young, when you were at the school, that's how you started learning a system, how you are training your mind in a very systematic way to follow, right? That's how you started. Now that is long time back. That is how you trained your brain how to follow a set of order or a set of instruction, right? Time has passed by, you have learned a lot of different things since simplification. And just not only that, you have seen that there are different complex problem also you have solved it, which has almost no relevance to the actual life or practical life if you think, right? But still, we have learned it. Why did we learn it? Because we were training our mind to think any complex problem logically, step by step, right? That is how we started learning about things. Now, why am I talking about all those things? You will see that for engineering mechanics, we actually we are not expecting you to remember, okay, these are the rules, that's how you draw the free body diagram, that is how you break the truss and then split the problem into two. No, that is not the whole purpose. You will see that through different problem, you will see there is a different lens at which you can see the problem. Okay, there could be a very complex problem, how you can have a basic assumption which can actually knock out a lot of complexity, and after that you can start with some really simple variable that you can deal with. Engineering mechanics will give you a very wonderful framework to think about that type of problems solving mindset. This is the biggest advantage, and this is the best thing the engineering mechanics offers you. I mean, this is what I think. If you think in different ways, so do let me know in the comment section. I would really love to know what you think. But anyway, let's move forward. Before we move forward, we'll come back to this slide a little late, but since it is just the starting of the class, let us talk about a few things which can give you the essence of the engineering mechanics. First of all, we have said that engineering mechanics is going to give you a wonderful framework to think about the subject, but let us go a few steps back and then think, where does this engineering mechanics fits into the overall scheme of thought? Now, to start with, if you look at the pictures that you have on the screen, the first picture is pyramid of Giza. I mean, you know that you have seen this picture many times, right? Now, you've seen this picture times, probably you know the timeline, but I would like to draw your attention here. Just check the time. What time frame that it has been built. It is a wonderful information if you just remember that. The time was 2600 BC. Okay, so right now when I'm recording this video, this is 2026 and this is 2600 BC. You can imagine how long the structure being built. Well, if you just look the next picture, which is Parthenon, what is the timeline? By the way, I mean, I think most of you know that the Pyramid of Giza, where it is. Parthenon, it is in actually Athens, which is in the Greece. But more than the location, let's look at the timeline here. The timeline is very important here because if you see the timeline here, it is 438 BC. So there is a huge difference between the timeline between them. I mean, all of them we actually categorize as like, okay, very old structure. But if you think they have like, almost, I mean, more than 2000 years of difference. Okay. Now, just remember this timeline. I'm going to add a few layers onto that, which will help you to understand what am I trying to hint you. Okay. So let's move to the next picture. I think you'll remember the timeline. Pyramid, 2600 BC. Parthenon, 438 BC. Now let's move next. You've seen these pictures as well. These are like, very popular pictures that I have taken. Now here, the first picture that you see, this is Eiffel Tower. You probably know it is in Paris, right? In France. Now, iconic structure, all of us knows, right? Check the timeline. Timeline is very important. 1889. So if I just go back here, if you just see here, it was the Parthenon, it was built 438 BC after a long time, like at least 2000 years, right? This Eiffel Tower, we are seeing it. So how much time we have passed in between this? Human civilization has gone through a lot of, rise and fall and lot of, decadal change in this time, almost 2000 years of change. Look at the next picture, which is Statue of Liberty. If you look at the Statue of Liberty, check the timeline, probably, I mean, मोटा-मोटी सेम ही एज है, राइट? आई मीन आईफिल टावर और स्टैच्यू ऑफ लिबर्टी, दोनों का जो टाइमलाइन का जो डिफरेंस इज नॉट दैट मच, isn't it? So we will come back to this point, but remember this timeline. Statue of Liberty, it was 1875. Eiffel Tower and Statue of Liberty doesn't have much difference, at least with respect to what timeline that you were talking about, right? We were talking about 2000 years of timeline, so it is not much difference. You can see that. Now let's look at the next picture. I have not put the name here. I think you know that this is Burj Khalifa on the left hand side, right? And on the right hand side, this is a picture. I mean, it's an iconic structure in India. Most of you probably know it. This is Statue of Unity. It is in Gujarat. And on the left side, you see the Burj Khalifa. I think it was built around 2000, 2004, around like, I might have forgotten that. But you see the structure, what we used to see, like that was 1875, 1890 around, like, come to the year 2000, like post 2000, see Burj Khalifa, how the structure looks like. You see, it's just not the photo quality, just check the structure, how it looks, right? I mean, on the right hand side, you see Statue of Unity as well. Well, from here, if you see, do you read something very interesting here? There's something very interesting here. If you just look, we are talking about a very wide range of time frame. We are talking about 2600 BC, and then we are talking about recently, which has been built. For example, we're talking about the Statue of Unity, isn't it? So here, if you think and imagine, what all differences do you see in the structure? I'll just run it through once again. Here you see the structure, old structure, how it looks like. Look here, how it used to look like. It's like, 100, 120 years back, how it used to look like. And the way we are making it at this point, look how does it look? The look has significantly changed. That is quite common. Nothing much to understand here or too much read about it. But just take a pause here. Pause the video here and just observe a few things here. I mean, what all differences that do you see? Well, if I just tell you the answer, the complexity has changed. If you look here, it looks like simple structure. Right now, if we think it was a very simple structure, right? But at that time, it was way advanced. It was very complex structure at that point of time. But today, if we just look at the structure, it doesn't look that complex to us, right? It looks very simple structure, right? As we move forward to the timeline, do you see the material that we have used here? This is mostly like, natural type of material with little bit of processing, isn't it? But if we move forward, what do you see in the Eiffel Tower? You see, this is not a regular type of material, naturally occurring material with a marginal change. Rather, we are using engineering material here. We are using steel. We are using concrete here, isn't it? Now, if you look even further right now, I mean, post 2000, you see something really amazing taking place. You see, even much more sophisticated structure has come up, isn't it? So, just not only the visual look, the way the type of material that we are using, the way we are designing different things, that has also changed quite drastically, isn't it? In fact, if I want to summarize everything here, complexity that we see earlier, it was difficult, but at this point, the complexity doesn't look as much as it used to look earlier. The material has changed. We are using much more refined structure. And one more thing that I skipped to mention here, if you look, Statue of Unity is just a person's statue. So we civil engineers, we are building the structure which is having the look of a human, right? This is called biomimicry structure. Basically, we are getting inspired, or we are building some infrastructure or certain building or anything that you want to call it, based on any naturally occurring thing. Burj Khalifa is also a wonderful example of biomimicry. Burj Khalifa, if you look from the top view, from the top, if you look, it is inspired from, I think, spider lily, if I'm not wrong. So the way, if you look if you look the Burj Khalifa from the top, it looks like spider lily. Okay, so you can understand right now we are just not worried about the look. We are trying, or we have understood things in such a way that we can design certain things which looks like human being or like any natural occurring things. So we have understood a great deal of the material, we have understood a great deal of design, we have understood a great deal of how material and different things behaves. That is why it was possible today, which was not possible long time back, isn't it? Now, just before that, I was just, quickly running you through the different timeline and showing you different pictures. So probably, I'll try to give you a different look in terms of the theory or the understanding. I was just, last couple of slides, I was telling it to you that, we have understood a great deal of the materials. We have understood how the material behaves, how things works, right? How did you develop all those understanding? Probably, next 2 or 3 slides, I'm going to talk about those things in a small details. Probably it will make you interesting about the subject, hopefully. So check the timeline. This is the timeline of the Archimedes. Archimedes actually said that, give me a place to stand and I shall move the earth. Now, if you just, read this statement, well, at this point, it doesn't make much sense to us, right? Give me a place to stand, I shall move the earth. Well, if you just, dig a little bit down and then try to understand what this great mind is trying to tell us, it is basically talking about the lever. You have understood about the lever, how first class lever, second class, different class of lever, how it works, right? He's actually talking about, if you have a lever and if you have a fulcrum, probably you can lift a great deal of weight. This is what the Archimedes is talking about. So at this time, just look at the timeline. This is 287 to 212 BC. At that time, Archimedes had a clear understanding how the lever works, isn't it? Check the timeline. Timeline is, we have been talking about the Giza, which is pyramids of Giza, which is 2600. After a long time, if you check the timeline, 287 Archimedes was born. At that time, he has postulated that, like, he knows about how the lever works, right? Very interesting and very insightful understanding, because especially if you just check the timeline, right? Now, today it just looks okay. Yeah, I have learned about it in my school days, but at that time, to come up with this thought, it was very, very novel. This is what I'm trying to tell you. Now, let's move ahead of the timeline. I think I just put the photos, but the photo somehow it's not appearing. But anyway, I'll just, go ahead with the timeline that I made. Like now, if you just check the timeline, like first we talk about the Aristotle. Check the timeline. It's 384 BC, 322 BC. That was the timeline the Aristotle came. So we know different theories of Aristotle, right? Here you heard the names many times. What I'm trying to give you is just an additional layer of time so that you can process this information in a organized timeline, right? That's the whole motive, because you have learned about the contribution of these great minds. I'm not trying to tell anything special about it, probably just adding one more layer of the timeline here. So Aristotle, check the timeline that he has come, and then check the timeline of Galileo when Galileo comes, right? Now one interesting thing you will see that, like the year the Galileo passed away, Newton, Sir Isaac Newton, 1642 he was born. The same year the Galileo died, the same year actually Sir Isaac Newton was born. Now, if you check Einstein, the timeline is like he came along later after Newton, right? So we need to understand, like, one person build up a theory with a lot of assumptions in the mind, and after that that assumption was there for some more time, unless and until the next great person came and then questioned the first assumption and then refined the theory. That's how we gradually developed ideas after ideas, and then which helped us to build up a good engineering sense today what we are using it. Probably a little bit details I will go. I'll just give you the timeline here. Aristotle, probably, I'll just timeline is very important here. Again, I think I'm repeating too many times. So check the timeline. In this timeline, Aristotle had the view of the positioning of an object. What does it mean? Like, in a different books, if we refer, it can be understood that Aristotle knew how well we can identify different object with respect to some reference point. Okay, so when we talk about the reference point, obviously, like, x, y, z coordinate comes up, right? I mean, today we use for engineering mechanics, just not for engineering mechanics, for any subject per se, we are going to use this quite a lot, right? So for the Aristotle, the view was this simple. So Aristotle said that there exists a prime mover who is at state of rest. That means there is somebody, not somebody, like, I mean, I can measure any point from a reference point. Now the point of the reference, that point is at rest. This is not moving. Okay, do not worry much if you are not understanding. I will help you to get this concept. If you can understand this concept, I think you will be able to appreciate what we are trying to do it. Even though it may not have any connection with what all engineering that you're doing, it probably will give you slightly little bit more outlook or interest in this subject. So in short, Aristotle was saying that there exists a prime mover who is at a state of rest. That means there exists a point which is at rest. With respect to that point, we can measure any point. If it is 2D, then it is x and y coordinate. If it is 3D, it's x, y, and z coordinate. That's what Aristotle said. That the timeline is, again, 322 BC when he passed away. Now, think how long time the human civilization has taken to challenge this view that Aristotle has put forward. What Galileo said. Galileo came when almost 2000 years later. Check the timeline here. Aristotle and the Galileo. Almost 2000 years later, Galileo came, and then he said that there is no such thing and as an absolute rest. That means you cannot say that, okay, there is a point which is always at rest. You cannot come up with that kind of which is absolute rest. There is always some point is moving with respect to something. Okay, so there is no such thing like, a point is an absolute rest. Now the question is, with respect to what? Let's say a ship is moving. So with respect to a person who is standing on the shore, the ship is moving. But what about the ship? I mean, if you and me both are sitting in the ship, with respect to you, I'm not moving, right? So what matters is the point of reference, right? So every point is moving with respect to something. There is no such thing called absolute rest. This is what Galileo said. But how long did it take for the human civilization to challenge the idea of the concept absolute rest? Well, we took 2000 years. Can understand? 2000 years, how many generations has come and gone? And this is the idea that we have got after 2000 years. Interesting, isn't it? Now let's see what happens to Sir Isaac Newton. Okay. uh, Sir Isaac Newton, if you check the timeline, there is not much difference between Newton, because I mean, I have drawn the timeline slightly now, inaccurately. The timeline is not, I mean, ideally this Galileo and Newton, these two dots should be closer to each other so that, like, timeline makes sense. But anyway, I think you get the picture. What I'm trying to tell you is Newton picks up where Galileo left. What do I mean? Uh, Galileo said that, like, if something is moving in straight line, it will continue to move. This is what Galileo said. If something is at rest, this thing stays in rest. Okay, so the idea was fixed. Means something is moving in the straight line, something it will continue to move in straight line. Something is at rest, it is going to remain at rest. What Sir Isaac Newton actually came and said, very interesting thing. He just added one clause more. Said that to get an object to change its velocity, we need force. You see, Galileo couldn't do that at that time. Galileo has come up and refined the thought process that Aristotle put forward earlier. Right here, he just added a new thing, like, what Galileo was saying, that if something continues to move straight line, it will continue to stop. Move in the straight line. Newton said that to change its velocity, we need force. This changes the entire gamut of the physical laws, right? I mean, that's why you study Newton's law, isn't it? So I think there is no need for me to explain the Newton's law here, but I think you get the sense here. Like what Galileo left, Newton added that, and that gave us a lot better understanding about the world around us, isn't it? Well, you see, from where we are moving, where we are, like, for an object to move, we need a force. This idea, we had it almost 350 BC. What we have realized now is, for an object to change its velocity, we need a force. That gives us so much of understanding, so much of concept to work with, which will make our life so simple in actual life. I mean, many of us actually joke around, like, if the apple didn't fall on Newton's head, this law could not have been done. But think, because of this law, how many things that human civilization has come up with, which has made our life so simple, isn't it? So I mean, things goes both ways as well. But anyway, I mean, what we are trying to tell you in the engineering mechanics, it's very important for us to understand the essence of it. Otherwise, क्या होता है, हम पढ़ लेते हैं, पढ़ने के बाद हम एग्जाम में मार्क्स तो कर लेते हैं, बट ये समझ में नहीं आता कि हमने क्यों कर रहे थे. So I think this is the most important part for you to appreciate the essence. Here, you will see that we will deal with a lot of complex problem in the real life. We will take it and, like, we will probably break it down in such a way that you should be able to solve the problem. Now, this engineering mechanics, does it have to do with the similar type of problem that you're going to deal with later? Very likely not. But let's say the world is getting more and more complex with time, where the multidisciplinary things are mingling together. So the concept of one domain is coming to the another one. I mean, this is what everybody is going to tell you, right? I'm not going to tell you that. What I'm trying to tell you is the concept that you're going to learn here. It will give you a framework to think about a different other problem. It will help you to understand the problem like an engineer, right? So engineering mechanics, think it is a tool. It is going to give you a framework. It's going to give you a skill to solving so many problems, so many complex problem in many different ways. You will see that same problem we can actually approach from many different angles. Earlier, the way you used to solve the problem, you used to know that, okay, if we solve this problem, we are going to, like, there are multiple ways to solve the problem. In engineering mechanics also, we'll see the same way, with an added advantage that you will see similar type of problem can be dealt with many different assumptions, and still you can come up with the similar type of solution. Assumptions would be different. Earlier, what used to be, the method used to be different. Now you will see the assumption would be different. If the assumptions are different, obviously the methodology is going to be very different. Hence, you'll see that we can come up with a similar set of solutions. Okay. um, so I hope, when you're attending this class, you will be able to, develop this mindset to think about the problem, just not for your engineering, many other small things that I think you'll be able to apply a lot of things. And more importantly, the word mechanics is very important here, because mechanics is how things works, right? This is the law at which everything works. So I hope, when we are saying engineering mechanics, understand that it is not, a pulley is rotating, or a screw jack is tightening a bolt, or like, some rotating motion we are trying to predict the projectile. Not at all like this. We are going to see how different engineering problem works in terms of their certain basic framework. With that mindset, we will try to approach this course, right? So I think at this point it should be clear to you, like, what are things that we are trying to achieve. We are going to go a little bit base and a little bit above that. With in addition to that, you're going to, if you want to develop even more, you can use different books to help understand many different things, right? So these are different books that I think you can easily follow. It's always good to buy the books, because what happens is, like, you'll see different problem when you're shuffling the pages. It becomes very easy to follow different problem, different answers. If you do it with the PDF, it sometimes may be difficult. At least for me, I used to find it a lot difficult. But anyway, you're a young generation. I think you will be able to find it even more swiftly. So, do it whatever you feel convenient. So a very popular book, you can see the name. This is Timoshenko, probably in India. This is mostly and most widely followed book. Very small book you can find, but this is morely or more on the static concept. And this is another important book I think you can check, which is J.L. Merriam Craig. You'll probably hear the Merriam Craig. I will keep repeating this book. You can check it from Merriam Craig. And then the other one is here is another one. So Merriam Craig, another part is there in the dynamics, so you can use this. So whenever we are covering different module, probably I'll give you a little bit more update on, like, which course material that you can follow. What I'll try to do is I'll try to give the content of the lecture in the description box, so that you can access that as well. So with that, I think we can stop this video here. Next class onwards, we will start this course on a full-fledged manner. I hope that you will actually love the way we will be learning together. So thanks, and see you in the next video.